Hello again and welcome to today's tutorial. We are going to be continuing our series on using QGIS. My name is Dr. Jude Jepu and welcome. Today we shall be teaching you how to do some basic tasks in QGIS. As I earlier mentioned, QGIS is a free and open software. You can check the codes or the source codes are available for you to modify, to create, to add to its functionality. And today we shall be exercising and doing some of these things that we can do using QGIS. As compared to ArcGIS, there are several things ArcGIS does a little bit more smoothly, more easily than QGIS. And also, there are some things that QGIS does more easily than ArcGIS. But in all, I think it is worth knowing that sometimes some of your employers may be pro free and open software, and they may demand that you understand and know how to use this free and open software. QGIS happens to be one of the best that is available and around. So a hybrid of these two skills, these two knowledge, as it were, it's required if you want to be a complete GIS specialist. So today we shall be demonstrating how you are going to load a scanned map and, of course, georeference it, because that is always the first task that we have in carrying out any GIS project. So how do you do that? All you need to do is to get to this raster area and click on the Georeferencer. May I say that Georeferencer is one of the core tools or core plugins that you have in QGIS. Means it is bundled with this program. And like I said, plugins can extend the functionality of this QGIS, where there are several plugins that you can, of course, load when you go to the plugin manager. And of course, you should be online for you to be able to use that. So I've got a few installed here. So whenever we need any other, we can always kind of install them here. But meanwhile, this is not what we're going to be doing, because of course we are going to show you how to do that very, very soon, because we're going to need some of these plugins for some of the visualizations that we will require to do. Meanwhile, you go to raster and click on Georeferencer. And like for this Georeferencer, you can georeference different type of rasters or scanned images, as it were. You can georeference PDFs, PNGs, JPEGs, EPSCs, several kind of data types that you can georeference. But today, we shall be showing you how to do that using a simple JPEG raster. So in doing that, we'll go to where we have our scan map, and that is Hungarian geology. It's a JPEG format, and here we are. We have it all loaded up here. So the next thing we are going to do is, if you look at this place, let me extend this place further. You see that there is no transformation at the set. All that is really just to show you the values of the rasters, and nothing is here. So what you're going to do first is to use this button to add points to this scan map. If you hover your cursor around here, it will show you that is where you have to add your points. So let us zoom in into this place so that the accuracy of our work will be greatly enhanced. So we have this. So if you left click here at the edge here, which is the border, and we click here, so it says you can enter the map coordinates. If you read this carefully, we see that if you have your X and Y coordinates in degrees, minutes, and seconds, you can enter the value of the degrees, followed by a space, the value of the minutes, followed by a space, and the value of the seconds. And if you have decimal seconds, you can also do that. So if you have them in decimal degrees, you can use that 10 point dot that one. So we have our coordinates in degrees, minutes, and seconds. So what we're going to do here for the easting, we have it as 6. We have space 00 and space 00. That's optional if you want to add this other 0 here. And for the northing, we have 10 00 00. Now you click on OK. You see this has loaded it here. Mind you, as soon as it loads it here, it converts it to decimal degrees because that is what it can work with easily. So the next thing for us to do is to georeference other 4 corner coordinates here, the remaining 3. That's what we're going to do. So if you come here, you zoom to layer, go to this place and zoom in again, zoom in to something that is reasonable, and then you click. Remember, you're doing your georeferencing, try to move either clockwise or anti-clockwise, just systematic movement, not just haphazardly. So you click on this place. This one is 63010. So we type in 6 space 30 space 00 and 1000, and we click on OK. So if you check out here, it has converted this to decimal degrees, which is 6.5. So it's time for us to go to the next point. There's corner coordinate, and here we have it at 630, 930. So we go to the edge here, click, and we have 630 and 930. Click on OK. So it has transformed it to 6.5 and 9.5. Then we zoom in here again, and finally we'll have it. Let's use this pan handler, and okay, we add points here, and the last point here is 600 and 930. Good, great. This is just wonderful. So now that we have the 4 corner coordinate, that is enough for us to have something that is very reasonable for our georeferences. So the next thing we're going to do is to click on this place and to transform these particular settings, transformation settings. Here we will choose, you can choose any of these, and for me in this case I'm choosing polynomial 1, and we are using the nearest neighbor. And for the projection we have the WGS 84 geographic coordinate system, and if I type EPSG 4326, it gives me this WGS 84, which is the geographic coordinate system I want to use. And in the output raster, if you click this button, you go to where you want it. In this case, I want it to be named georeferenced, georeference Zungeru geology. The file type is TIF, that's the geotiff, and compression, we say we do not need any compression. And here, if you need to generate a PDF map of this your georeferencing, you can also do that. So let's click here and let's go to this place and say georef again. Georef, I made a mistake. Georef again, Zungeru geology. All right, so we save. So at the end of the day, do we need to generate a PDF report? We don't need it. Load in QGIS when done. Yes, I want to load this thing when it's done. You click on OK. So the last step in this series is to click on this place, which is to start georeferencing. Once you click it, you will see the progress button, and now it has finished. So all you need to do is to exit. But also, okay, let's just exit. Now it's also it's asking if you need to save the GCP points. We save it in case you want to reuse it later. We'll save it. So now this thing is loaded here, the georeferenced raster. Now if you hover your cursor around here, we can see that from here, look at the coordinates. Yeah, so if we zoom in to this place, this is actually 6,930, and come here, you see that the value here shows very, very close approximation to what we have. And of course, you can use this scale button to scale it to anyhow you want it. If you want it at 1 by 50,000, this is how it should appear. And depending on the scaling you need, I can say we need it 1 by 250,000. It appears this way. So the magnifier here is 100%. The rotation here is at 0 degrees. We can render, and this is the EPSG code, or the reference coordinate reference system that we are using. Okay, so now that we have got that in place, we can now start doing a lot of things with this, because we can now digitize and do all sorts. But for example, that's demonstrating it. And if we need some other data sets that may accompany this particular map, we can also download them. And that is part of this exercise to show you how to use GIS to download this stuff. And in doing that, we can use the OSM downloader. We can go through the hot OSM website. There are several things we can do. But let's start with downloading using the OSM tool. So if you go to your plugins here and go to manage and install plugins, we want to download the OpenStreetMap tool. So if we go to all here and search for OpenStreetMap, okay, it's not OpenStreetMap, it's OSM. Okay, so we have this all that, and the one we need is either this quick OSM. If you need that, you will see the information that is given here, and if you need to do this OSM downloader, and this is the one we need because you can download OSM data using this particular thing. So let us install it, and now that it's installing, it has finished installing, so we have that checked. We can close here. Then we see that the plugin is available here. So all you need to do is to use that, and of course get to using a rectangle. You can now do whatever you want to do. But before then, I want to show you how we can, let's just check this off, how we can import the CSV files and create a polygon that covers this particular area. So we go to layer, and we are going to add a layer, and in this time we are adding a delimited text layer because I already have this coordinate saved as a CSV coordinate. So you click on this button to browse, and this is my coordinates. It's in CSV. You open it. So it is, the file format is .csv, which is correct. You can expand this to show you some of the things. First thing, first record has field names. Of course, this first record has field names. Automatically dictate field types is there. If, for example, your data is not clean enough, you can ask it to clean this. Of course, we don't need to check this because the decimal separator is a comma. Sometimes you may have it as a colon, a semicolon and all that. So this one will prompt you to discuss empty fields if you have any, but that is not the case here. Everything seems to be okay here. We can go to geometry definition, and this here is the point coordinates. So what is the X field? The X field is the long, and the Y field is the lat. And do you have it in DMS? No, we don't have it in DMS. What is the projection here? We use the APSG 432, but we can go here and search for it. So we can go and search for 4326, and that is the coordinate system where we have it. So, and for the layer settings, we don't need to add anything here. So all we need to do is just to click on add, and that is oh, sorry, we have not selected this. Let's select this. All right, so input coordinates, this is the long and this is the lat, and all seem to be working fine as it were, and we click on add. So close. So oh, we have already added it. Okay, the first time it worked, sorry. So we can also remove this. Okay, so now we have it. So these are points, and we need to create a polygon to actually cover the area where we are interested in. And so for us to do that, we are going to be using the processing toolbox. You go here and we click on the processing toolbox. So what we are going to do first is to do points to paths. So once you can search for anything. If you want to go through them one by one, it can seem a little bit overwhelming at first, but you can also search. So once you click on put this input of points, you can see all the tools that are read. But the one we are looking for is points to paths. So let's where is it now? Points to paths. Okay, we have it here. That's vector generation points to paths. So we double click on that, and it now comes up. So what are we using? The input point layer is the coordinates. Close path, it's saying yes, we want to close the path. And in this case, we have to put the other field. The other field signifies how it is going to use the order it will use in closing the path. And we have the order as 1, 2, 3, 4, as it were. And a quick look at our data, for example, if we open it, it will show you how these things are actually created, because we see we have this order. So it will close this first, close this second, third, and fourth. That is the way it works here. So let's go back here, and we'll see the group field. Of course, if you want to, there are some of the activities that you want to do that will require this, but this is very optional. And every other thing seems to be okay. We'll click on run. And in that case, it shows us that this particular thing has finished. We close. So we see that this particular tool has closed this part. But then this is just a line string. We need this thing to be vectorized. So we'll just click lines to polygon, lines to polygon. All right. So yes. So what we want to do is to convert these lines to polygons. We click here. So we already have our parts loaded as our line, and everything seems normal. We can just click on run, and something is finished. So we see we have been able to create our polygon that covers the area. So we can check this off and check this off. So now that we have this is our polygon, we can also style it. So we can go to properties, and we'll check the properties out. So here it's having a simple fill. In this case, we want the fill color to be transparent fill, and for this time we will just say okay, that's what we need. We don't need any more than that. So we can click on apply and click on OK. So we have it transparent. So if we check on this particular box here, we'll see that this thing covers where we have our polygons. Okay, let's continue to do and make the line a little bit thicker, and let's go to this fill, simple fill, and let's fill with solid fill style or empty. So we go to the line, and this is solid line here, and we need the line to be thicker. So let's say 1 here, and we click on apply. So you see that this line has appropriately covered the area where we need to digitize. So that is how we can create a square polygon around a particular place that we have georeference. So, and the next thing that we're going to do is, okay, we can seek for data, and supposing we check this thing off here, we can now use this particular OSM tool and download some data that we'll be using for this particular project. So if you click on this place, that is the OSM downloader tool, and you left click here and drag. So this actually fills the area where you want this thing to be. If you are not satisfied with the selection you made, you can always correct it here. Remember, we had it as our 10.00, and this we had it as 9.5, so we can manually correct it. We had this as 6, and we had this as 6.5. So let's make this a little bit pretty. And where do we want this file to be saved? We want it to be saved here, so we'll now save it as Zungero. Give it any meaningful name that you can work with. Load layer. After download, let's say okay. So it will take some time for it to load, so I'll pause this video right now and allow it to download. It's still downloading, as at this time around we have 100 megabytes, and it's still downloading, so we allow it to finish, and when it finishes, we will now load this particular data set. So as it were, it has finished, and it displays success. The file has been downloaded. So at the end of the day, we had about 146 megabytes from the OSM servers, and we can click that, and it has loaded. So we will see that there are different things that has been loaded here. We saw the ones that has the names of the places, the toponym, because it has the names of the cities, the villages, and the hamlets. And if we right click on this and go to properties, okay, no, not properties, let it load. We're going to look at first the attribute table, So we go to this, we open the attribute table. So we're going to take a look at the attribute table. The features are being loaded right now, so many of them as it were. And once it finishes loading, we are going to view the attribute table. So here we have several columns having different variables, and that is how what it shows. So we have some variables showing parks, and if you come here, we have some showing village names and all these things here. So several of them. So in order for us to use this in several other maybe software, for example ArcGIS, of course ArcGIS can recognize some of this OSM data, but it's imperative that we give it a particular thing that it would work with easily. So we can right click on this, export it, and save feature as this one is OSM points. Which format do we want? We want it to be, for example, H3 save file, and the name, let's make sure we are in the right place. We have this, the name will say they are OSM points, and we click on save, and the layer name, all this is the CRS, we want it in geographic coordinate system. Every other thing seems to be okay. We now click on OK. You can add it on the save map, it doesn't matter. We click on OK. So right now it's adding it on the saved map. So we can, of course, check this off, and we still have all this here. So this is the points that we have saved. So you can do same for the lines, for example. So if we check this off, we don't have the points anymore. We come to these lines here, and oh, this thing is loading. Let's give it some time to finish loading. Okay, so we have them loaded. So if we check this off now, you see a lot of the lines have disappeared. If we check this on now, you see a lot of lines are here. So this is how we do this. You can still go ahead and save this and export, save feature as OSM lines. OSM lines, let's make sure that it's in the right folder, and we'll click OSM lines. This could be used in other software. Everything is okay. We can add that to our map. And most times I don't find these multi-strings to be of much importance. And but you can now like look at them and check them out later. All these multi-polygons, these cover maybe developed areas and all that. It's not really much use for us. For geologic studies and all, so most times I don't really have much use for them. So that's about it, how to go about doing this. You see a lot of lines and all that. So this one has finished and it's loading them. So that is how you can get some of this data, and how you can work with some of this data. For example, if we put all the OSM lines and get to open the attribute table, we'll see that we have several columns. Some have got names, and some indicate they are highways. We have waterways, because you can see that some places are rivers and all that. So we can see aerial way and all that. So these are the variables that is contained within this particular data set. So we have several rivers here, several lines, some federal highways and all that. So in a much later video, we'll talk about how to use this and how to style it, of course. So this is part of the way we can do that. So the last thing I want to demonstrate is how we can maybe use some base maps in this particular work. So how do you get base maps? We'll still use another plugin. So we'll go to our plugin manager, and what we need this time around is the quick map service. So let's say quick map. Okay, so we need the quick map service. So it's easy to use this of finding data sets and base maps. So when we install the plugin has finished installing. So we have that, it's installed successfully. So we can close this, and let's check this off to reduce the load. Okay, so we'll go to this place and to web, because it's always located around this web, and quick map services. So there are several base maps that we can download, or several other data sets. Like this one says you can have the earthquake distribution. This one will give you an OSM standard base map and all that. So, and in this case, let us choose the standard OSM standard base map. You see it has loaded a base map here. So once we zoom in, we can see a lot of this base map that we can use for our service. There are several other kind of base maps that you can use. All right, so we are continuing. So you can still use this, apart from this OSM, you can still go to this place, quick map services, and go to search QMS. Here you can actually search for different types of data sets. So for example, if you search for Google, and you will get different data sets appearing for you. You can look at Google normal, Google CN satellites, but let's just use this one, this Google satellite here. We can add that. Remember, once you add it, it comes under this particular one. So you can either take it up here, or you can check this one off. So we have this as the Google. This mimics the kind of thing you see in Google Earth image. So this is how you add several base maps. You can experiment with it, search for several. There are just so many. We can search on Bing. We can have some Bing maps, and it may show you area. Let's see if we can have some National Geographic data sets here. So it searches online to see if we can have that. So, but you can just play around with it. Most times, I've not found so much use like this S3 National Geographic. You can add that for the. Or remember, most times it adds it under. If we check this off, we'll see this National Geographic base map for the area where you wish to study. So this is what we can do, and in the next video we are going to talk about how to create some shapes. In this case, we learned how to, in this map, how to create our polygons and lines, how to georeference, how to do some of these things. So in the next video, we are going to show you how you can do a lot of this stuff, like creating lines, creating points, and creating even some other irregular polygons, as it were. So I hope this video has been instructional, informational, and if words will permit me, I hope it has really taught you something. So long for now. Bye.